This UCSD TV program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest programs.
We are the paradoxical ape, bipedal, naked, large-brained, long the master of fire, tools, and language, but still trying to understand ourselves, aware that death is inevitable, yet filled with optimism. We grow up slowly. We hand down knowledge. We empathize and deceive. We shape the future from our shared understanding of the past. Carta brings together experts from diverse disciplines to exchange insights on who we are and how we got here. An exploration made possible by the generosity of humans like you.
As humans, we often ponder the pleasures of life, right? Things like good food, a drink with friends after a long week of work, right? Falling in love, that's a great thing in life, right? Spending time with family. These are all undoubtedly great things that we enjoy in our lives. I'd also argue that sleep is one of those great things in our lives, right? There's nothing better than sleep when you're truly tired. And the feeling of climbing into bed, pulling up the covers, putting your head down and falling asleep is pure bliss. And we see this in cases of extreme sleep deprivation. For example, here's a picture of Peter Tripp. He was a DJ in New York in the 1950s, and as a publicity and fundraising stunt, he tried to stay awake for as long as he could. He managed to stay awake for over 8 days, which is pretty remarkable, on the air the entire time. What's even more remarkable to me is that others came along and actually beat his record. I can't imagine why anyone would want to do this. But on a less extreme scale, I bet that most everyone in this room follows the same pattern that I do. And that is we sleep too little during the week, and then we catch up on sleep on the weekend, right? And so I bring up these examples to illustrate the love-hate relationship that we seem to have with sleep. On the one hand, we love sleep, and people often say, I love sleep. But on the other hand, we always have something better to do than sleep. Isn't that right? Sleep is seen as something that we can do without, or that we would like to do without. And certainly we cut into it very commonly. And so just like we hear people say, I love sleep, we also hear them say, I wish I could function on less sleep. Now, today I want to present some findings from my lab over the last couple of years that suggest that this love-hate relationship is not a new phenomenon. It's not a new phenomenon associated with television or social media or artificial lighting or all the other kinds of evils you might think of if you're a sleep medicine or sleep biology. Instead, our findings are suggesting that that natural selection has been whittling away sleep along the human lineage probably for millions of years. And we also think that this might have implications for understanding some aspects of human health. So I want to start with a little bit of background. First of all, what is sleep? Sleep is a reversible state of rest, right? So it's not like a coma. It can be easily reversed. Sleep can. It involves reduced awareness and responsiveness to surroundings. It involves a rebound effect. I just talked about that with our catch-up sleep that many of us are going to have tonight after this long week of work and travel and everything else. You have to compensate for lost sleep. And very importantly, sleep is not one thing. It's actually two different things. Sleep, when you're not awake, you're actually in two different states. You're in non-REM sleep or in REM sleep, rapid eye movement sleep. And this is, of course, REM sleep is, of course, when the most visual dreaming occurs. And a sleep biologist can differentiate these two stages based on EEG. Now, I want to just walk you through what would be considered an ideal or normal night's sleep. This is showing an 8-hour time period from about 11 p.m. until roughly 7 a.m., so an 8-hour block of consolidated sleep. And ideally, you would fall into the deeper stages of non-REM sleep first. You'd spend some time in non-REM sleep, and then you'd actually arouse out of non-REM and go into REM. It's a different stage. It's not just a deeper stage of non-REM sleep. That cycle then continues throughout the night. You go into a second bout now of non-REM sleep into deep, slow wave sleep, and you come out into REM sleep. Now, periodically throughout the night, you would also awaken. I want to really focus on one question today. How does human sleep differ from the sleep we see in other primates? And I want to be a little bit more provocative and ask, are humans evolutionary outliers in terms of the kinds of sleep that we have, in terms of the characteristics of our sleep? And so, of course, we think in evolutionary anthropology a lot about how humans are different from other primates. Often those are questions about discrete traits, qualitative traits, right? Bipedalism, how we use tools, or whether we use tools, or whether we have a theory of mind. Here I'm interested in a quantitative trait, the characteristics of sleep. And so I need to first define what I mean by an evolutionary outlier. This is a trait that's more extreme than one would predict based on the modeling of trait evolution on a phylogeny, on an evolutionary tree. So based on what we know about the various socio-ecological factors that influence sleep in primates, as well as the phylogeny and where we fall in that phylogeny, we can predict sleep characteristics in humans. So for example, we know that predation risk across mammals will tend to reduce sleep times. If animals do not have a safe place to sleep, they sleep less. And so we can use that knowledge across mammals to actually predict what human sleep would look like. And then, of course, once we have a good prediction and some confidence intervals on it, we can ask, where does our observed value of human sleep fall compared to what is predicted? And if it falls outside that distribution, we would be an outlier. We're different from what you would predict based on what's known about sleep in other primates. And so we use a method that's been developed in my lab called phylogenetic prediction, where we use a statistical model in phylogeny to predict a phenotype in a particular species, in this case humans. We basically have a bunch of different variables that can go into this, and we estimate these parameters in the model, and we also incorporate evolutionary history. We implement this, we make estimates of this model using a Bayesian approach that produces a posterior probability distribution of predictions. So this is what you might see in this kind of a case. We use this approach and we come up with a posterior probability distribution of predictions as you see here. Then the question, of course, is where do humans fall? Are we above this distribution? Is our observed sleep time above this distribution? We would be a positive outlier. Or we could be a negative outlier. The observed value falls below this distribution. Or we can be about what you would expect if we were a typical primate. So the critical question in all of this, of course, is what value do we put on this distribution? Okay, and so what is the duration of human sleep? What would be a good estimate of the duration of human sleep? Well, here I'm going to use a value of 7 hours, and I think that's a fairly conservative estimate based on several different lines of evidence. Some of this evidence is from our own work, studying a traditional population, agriculturalists, who live in Madagascar, and they're a population without access to electricity. And in this population, I'll talk about this in a little bit later in my talk, we find that people sleep on average 6.5 hours a night. We've also studied the Hadza hunter-gatherers, and there we find that the average sleep time is 6.2 hours per night. Likewise, a recent study of 3 hunter-gatherer groups found that the average sleep time across those 3 groups was 6.5 hours, pretty short. These guys don't have TV, right? They don't have all the things that we have, the social media and all the other, and the artificial lighting, and they're actually sleeping a little bit less. Another study of a non-electric population also gives 7 hours, or we can look at Western populations, and it's about 7 hours in a recent meta-analysis. And so we think that this is a conservative estimate of typical human sleep, 7 hours. Okay, so here's a picture of a Hadza man sleeping with his fire, some weapons next to him, and on the ground, right, which is different from most other primates. And I just want to share with you the 3 things that we've found from our analyses. First of all, humans sleep less than would be predicted, so we're a negative outlier. We spend a greater proportion of time in REM sleep, that rapid eye movement sleep, and we are very flexible in our sleep, more flexible than would be predicted. All right, so let me walk you through the evidence for each of these 3 points. First of all, here's the distribution of sleep times for primates where we have data, okay? And we have a pretty good number of species now studied for their sleep. And what you see is that humans are the shortest sleeping of all the primates. Now, again, we want to control for phylogeny and for these other ecological variables, and so we've used this phylogenetic prediction approach that I talked about. Here's our equation that we're using to predict sleep duration in humans, and here's our posterior probability distribution of those predictions. And what you can see is that the observed value falls below this distribution, right? We are a negative outlier. In fact, the mean predicted sleep duration for humans is 10.3 hours. From this analysis. And we're clearly different from that. Here's the second result involving REM sleep. Humans, again, have the highest percentage of REM sleep of all the primates. Now, again, we wanted to use this outlier approach, this phylogenetic prediction approach. And so, again, here's our equation relating REM sleep to activity period, body mass, brain size, diet, interbirth interval, group size, and phylogeny. And you can see the posterior distribution in this case, and here's the observed value. So here we're a positive outlier. And we know that this is achieved via higher than expected REM sleep. So if we just look at the total amount of REM, we're looking here at the percentage of REM, but the total REM, we have higher than expected REM and less than expected non-REM. It looks like both of these are shifted. Okay, then the final set of results I want to share with you involves a hypothesis that we came up with based on the ethnographic literature, based on experimental studies, and based on the historical record. And that is that natural human sleep is more flexible than we usually appreciate. And so let me just walk you through some of the findings that were already out there before we came into this sphere. Here's an example from the ethnographic literature, work by Dan Everett on the Piraha, South American hunter-gatherers, where he reports that the Piraha take naps, 15 minutes to 2 hours at the extreme during the day and night. There's loud talking in the village all night long. Consequently, it's very difficult for outsiders to sleep well among the Piraha. And in a more sort of a review article of all of this ethnographic literature on sleep patterns, Carol Worthman notes that human nights are filled with activity and significance, and nowhere do people typically sleep from evening until dawn. In terms of the historical record, some of you might be familiar with Roger E. Kirch's work, in which he looked through the historical record in multiple cultures in Europe over the past couple of thousand years and found evidence in much of the written record there for references to a first sleep and a second sleep with a period of nighttime activity in between. Okay, and so he found evidence for what would be called segmented sleep. And likewise in experimental studies, for example, Tom Ware's studies, when he put humans into a long night condition, so a 14-hour condition where people were not allowed to have access to lighting, they shifted into a biphasic sleep condition, so again, segmented sleep. Of course, other primates also show nighttime activity, but my colleagues and I in my lab have hypothesized that humans are more extreme than other primates. Well, unfortunately, we don't have data on other primates, but we can look at how flexible sleep is among people living in traditional populations. So as I mentioned, we've been doing work in the Hadza. This is work led by a postdoc in my lab, David Sampson. We've been doing work in the Hadza using actigraphy devices that are just watches, basically, that measure activity levels. And from that, with algorithms, we can make inferences about sleep. And also in the Malagasy population, the agriculturalists, we've been using actigraphy, but also EEG. So we actually have the gold standard measure of sleep in one of these two populations. And I just want to share with you some of the things that we find. This is a big table, but let me focus on two elements in it. This is total sleep duration in the Madagascar population, 6.5 hours, as I mentioned previously, compared to 7 in a typical Western population, in this case in the USA, using the same techniques. Likewise, the sleep fragmentation metrics are much higher in the Malagasy population, and sleep efficiency is much lower. So they're up a lot more during the night. Likewise, we found some evidence for segmented sleep, the same kind of segmented sleep that Roger Ekirch has documented in European historical record. So this is showing a functional linear modeling of circadian patterns among the individuals in our sample, and this is the nighttime hours in this population. And what we find is a significant bump up in activity, especially in men, just after midnight, for a substantial amount of time, in fact. And this is at the time when there's over 12 hours of darkness in this population. Okay? So they're winter. And as well, we find in the Hadza hunter-gatherers that once they go to sleep, there can often be long periods of wakefulness and quite fragmented sleep, as you can see from some of these plots, where the dark lines are indicating sleep time, with the first one being the inferred sleep onset, and then lots of activity at night. Okay, so I want to wrap up with 3 questions very quickly, go through 3 questions. First of all, why are humans such short sleepers? What is going on with this? Based on this, should we be short sleepers today? Is this giving us some reason to think that maybe we don't need all of this sleep? And then finally, does the evolution of sleep, of short sleep, potentially affect health? Okay, so why are humans such short sleepers? Our answer to that is that just like today, throughout human evolution, our ancestors have had better things to do than sleep. And some of the potential selective forces that might be at play to shorten sleep along our lineage is that we sleep on the ground. And we know from other species, other primates, there's greater predation risk on the ground. If you are experiencing greater predation risk, that should select for less sleep. As well, being on the ground may expose individuals to greater inter- and intergroup conflict, where it would be easier for a conspecific, another member of Homo sapiens, to attack at night because of this terrestrial sleep. But as well, sleep comes with opportunity costs, and one of those involves social interaction. When you're sleeping, you're not socializing, and we know how important socializing is for humans, and in particular, it's important in the context of social learning, right? And from the awake time to acquire and transmit new skills and knowledge. So we think that many of the things that have made humans so successful have also favored less sleep. Now, as well, the higher percentage of REM sleep may relate to this last issue because it's thought that REM sleep also plays a role in consolidation of memories and simulating various kinds of threats and problem solving. So do these results suggest that we should sleep less? Should we be considering a paleo sleep plan of some kind? I think our findings and those of others are suggesting that a paleo sleep plan would involve very short and fragmented sleep, very brutish in another way. And I think we can turn to evolutionary medicine to help us think about this issue. A central tenet of evolutionary medicine, as we've heard in the previous talks, is that natural selection operates on reproductive success, not on health. In fact, short fragmented sleep is associated with many poor health outcomes. Those include cardiovascular disease, higher rates of cardiovascular disease, metabolic dysfunction of various sorts involving diabetes, for example, and cancer, right? So there are serious problems with having a short fragmented sleep. Yet many of these problems would actually occur likely later in life, post-reproduction and the selection shadow. And so perhaps we need to think about whether reproductive success is more relevant to us today or health and longevity. If reproductive success is important, maybe a paleo sleep plan is a good one, but I bet that most people in this room are more concerned about health and longevity, in which case this is probably a bad idea. And in fact, I would suggest that humans today are having the best sleep that we've ever had in our evolutionary history. And, so you could imagine that this gentleman's having a much better sleep on average than this individual is going to have tonight. And there are many reasons to enjoy this for those health benefits I just mentioned, as well as for better cognitive function, better immune function, et cetera. Does evolution help us understand modern sleep and sleep disorders? Of course, many people do not get to experience this kind of nice, relaxing sleep, consolidated sleep. For example, many people, about 10% of the US population, has some kind of insomnia. And based on our findings, I guess one question that arises is, should we really expect to sleep through the night every night? That doesn't look like it's really been a part of our evolutionary history. That seems to be a modern phenomenon that we strive for. And so perhaps middle of the night insomnia is not so unexpected, especially for those of us that may have ancestors who had that kind of segmented sleep pattern. As well, you could imagine that individuals who experience threats of various kinds would have an adaptive response to not sleep. And of course, in modern society, many people do still do experience these threats. People living in inner city environments, for example, or people in a relationship where there might be domestic violence. As well, there's societal threats, such as racism. Many people are now showing that these kind of threats affect people's sleep, leading to sleep disparities, and they're even linking that up to some of the other health disparities that are known, for example, among different racial groups in the US. And so finally, does the evolution of short sleep help us to understand disease? Is there a case of that? Recently, Randy Nesse, Tuck Finch, and I proposed that this may help us understand Alzheimer's disease, which is thought to be a uniquely human disease, as we heard previously in Ajit's talk. And this really our idea relates to the glymphatic system. This is a system of the brain that's only recently been discovered in the last several years. It's an amazing set of discoveries. And this glymphatic system is involved in removing metabolic byproducts, including amyloid beta, which is involved, of course, as you know, in Alzheimer's disease. And so a lot's being learned about this system, of how the cerebral spinal fluid moves through the brain and picks up various kinds of pollutants in the brain and carries them away. And most importantly for our hypothesis is that this system functions most effectively during sleep. So we're proposing that this is one trade-off, there are probably others, of evolution acting to reduce sleep along the human lineage. So I hope I've convinced you that this evolutionary perspective is useful for understanding this love-hate relationship that we have with sleep. And I want to thank you all for staying awake. I didn't see anyone sleeping. Thank you. And I want to especially thank my collaborator on a lot of this, David Sampson.